Hello, this is the fourth video of a Linear Programming 2 series on the simplex method and integer programming for OCR Discrete Further Mathematics. And we will be performing iterations on the initial simplex tableau. In the previous video, we set up this initial simplex tableau, remembering that the objective function is in the top row. To represent the information in the example augmented linear programming problem, as shown by these four equations here. You may have looked in the OCR formula book and seen the simplex algorithm written out like this. We will now work through these steps to make them clearer for you. We'll start with steps 1 and 2 of the algorithm. You may wish to have your formula book open beside you while we do this. For step 1, we're going to choose a pivot column, and we do this by looking at the negative entries in the objective row. We have a choice of either the X column or the Y column. We're going to look for the most negative, in other words the X column, because this is where the variable and will give the fastest increase when we alter it. And this in the long run means that fewer iterations will be required within the simplex method. So, choosing this column then as our pivot column is step 1. Step 2 is to set up what we call a ratio test. To do this, we take these right-hand side values and we divide by the pivot column value in the same row. So here we would have 0 divided by minus 10 would still be 0. And generally, the objective column ratio tests can often be negative and discounted, because we're looking for the smallest positive ratio test value. 12 divided by 1 would give us 12. 30 divided by 2, 15. And 20 divided by 2, 10. So this is the smallest positive ratio test, and thus this will be our pivot element. Moving on to steps 3 and 4. We want the pivot element to be 1. So therefore we divide through that whole row by 2. This will give us then a value of 1, a half, 0, 0, don't change, a half, and 10. It's worth making a note of those because the operations on all the other rows will be related to this new pivot row. In step 4, we use a multiple of this new pivot row, either added or subtracted, so that the pivot column becomes all zeros except for that single new pivot element of 1. So for this minus 10 to become a 0, we need to add 10 of what I'm going to call row 4. When I do that, I would have 1 plus 10 lots of 0 is 1. Minus 10 plus 10 will give me the 0 I want. Minus 9 plus 10 halves, remembering I'm using the new values, would give me minus 4. And then I have some zeros that are not going to change. And then I have 5 lots of a half to add to 0, which will give me a 5. Then the right hand side will give me 10 lots of 10, giving me a value of 100. With the next row, I've got a 1. And therefore, I just need to take away 1 lot of row 4 to make that a 0 there, which is what I'm after. Remembering that I want that column to end up looking like that. You'll note that where I added to the objective row because of a negative, I will be subtracting multiples of row 4 from the other constraint rows. So this would give me 0, 0, and then 1 minus a half would be a half. I'll write that as 0.5, but I could keep it in fractions. Sometimes fractions are better if they're more exact. And then 1, 0, minus 0.5, and I have 12 to equate 10 gives me 2. And then I need to take away 2 lots of row 4. 0, 0, 2, 0, 1, minus 1, and then a 10. The row 4 I have already worked out from above. Looking at the objective row, the top row, we notice there is still a negative element, and therefore the algorithm requires another iteration. So step 1 is choosing this column, the Y column this time, as the pivot column. Doing the ratio test would give us minus 25, giving 4. 10 divided by 2 giving 5. 20. Remember, we want the smallest positive. So therefore this 0.5 is now the new pivot element. Moving on then for steps 3 and 4. So we note in that column that we're going to want a 1. So we need therefore to multiply by 2. And that would then give us our new pivot row, of which we're going to match the others. So that's why we add the 4 of row 2, this new row 2, to that objective function row. We then need to take away 2 of this new R2 to ensure that we end up with the right numbers, in other words a 0 there. That would give us 0. And finally, by taking away a half of that row 2 in order to gain that 0 there, the end of our second iteration. We can note now that in that objective row there are no cells or values less than 0. Therefore, looking at step 5 of the algorithm, we have found an optimal value. In summary, we need to formulate the maximising problem as a tableau using slack variables as necessary to get that augmented form, making sure that all the elements in that last column, except perhaps the top one representing the objective function, are non-negative. So then we select the column whose top element is the most negative. So this is step 1, and it's called the pivot column. Step 2 is to perform the ratio test and choose the positive element in the pivot column for which the ratio is smallest, noting it does have to be positive, and this is then the pivot element. So we then have to make the pivot row have a 1 in that pivot element, so we divide it by the pivot element. Then we use this new pivot row to reduce to 0 all the other elements in the pivot column by various operations, which is useful to state to the right. And we go through these iterations until all the elements in the top row are non-negative. Then we know that an optimal solution has been reached. In the next video, we will interpret the simplex tableau in greater detail and identify that optimal solution from it.